Good morning. Let me introduce my PhD topic, which is 3D printing in dentistry. My name is Németh from Department of Prosthodontics, and my vision is a high-quality digital prosthodontic treatment using 3D printing technology as a daily routine. And to reach that, I would like to bring 3D printing to the clinical practice. My specific goals are to evaluate the accuracy of this technology through dental models and fixed dental restorations. So my first project is a clear guidance to select the most accurate technology for 3D printing dental models. I'm at the stage article writing with final results, and my plan is to finish the draft in June, and I would like to submit this article to Journal of Dentistry, which is a D1 journal. So the biggest breakthrough in dentistry was the advent of CAD/CAM technology because it comprises time-saving manufacturing and precise restorations. It comprises additive manufacturing, as known as 3D printing or rapid prototyping. During that process, the three-dimensional object is made up from a digital model, layer by layer. The importance of this topic is shown by the increase in the number of publications, and there are several types of 3D printers with different technologies and different printing parameters, but the problem is that the results in the literature about the accuracy are different as well. And there are several cases where the 3D printed device accuracy is crucial. For example, if the implant location in a 3D printed cast is inaccurate, the prosthesis made on it will be not precisely fitting and unusable. So we need more evidence about the dimensional accuracy of this technology, and our aim is to evaluate that through 3D printed dental models. So we would like to compare 3D printed dental models to the initial digital reference file. And our hypothesis is that the accuracy of printed models is within the clinically accepted threshold, regardless printer type. From prosthodontic aspect, this limit is 120, and from orthodontic aspect is 250 micrometers. I made my systematic search on these 4 databases with this search key. And I ended up after duplicate removal with more than 16,000 articles. And after the selection, I had 32 eligible articles. Because of the heterogeneity of the included studies, we needed to make a subgroup analysis according to those factors which have the greatest effect to the printing accuracy. The first one is layer thickness. Because it largely affects the surface quality, we can see the difference running the printing between 100 microns or 16 microns. The second factor is the model design. According to a study, these horseshoe-shaped models are significantly less accurate than those which have this connection part, so we needed to separate these models as well. The third factor is the measuring level. We can examine the accuracy on full arch or on smaller segments. We call them arch level and tooth level measurements. The software making the superimposition between the reference and the 3D printed models can express the discrepancy with different values, with root mean square value or with absolute mean deviation. Root mean square has this equation to calculate the values in the positive way, and it results in a 3-dimensional analysis, and the absolute mean deviation is the mean difference between the 2-dimensional measured data. So because of this difference, we needed to separate these articles as well. So at the end, I had 7 subgroups according to these main factors. Now let me show you some of my subgroup results. The first one is RMS trueness at arch level using layer thickness 0 to 50 microns. According to the extracted data, we were able to make a network meta-analysis where we can compare the different interventions to the control group and the different treatments to each other as well. We can combine both direct and indirect evidence across a network of studies. In this leak heat plot, it contains the deviation results for all possible pairs of treatments with 95% confidence interval. And the forest plot shows actually the first row of the leak heat plot. Here we can see the null effect line, which is the value of the reference group. It's, in this case, 0. The different interventions and the mean difference to the control group. Here we can see all of the technologies are within the orthodontic clinical tolerance, but only PolyJet, DLP, SLA, and multijet technologies were acceptable for prosthodontic applications. These differences are statistically significant, but clinically they are not relevant. In another subgroup, the measuring level is tooth level. We can see all the technologies performed within clinical tolerance, and the reason is if we examine the trueness in smaller segments, the distortion is much moderate. And in another subgroup, we were able to compare different DLP printers to each other as well. And as seen on these figures, the mean difference between two DLP printers were only 6 micrometers. Besides that, SLA and DLP technologies were within the prosthodontic clinical tolerance, but FDM is not acceptable for this application. So the strength of this research is that this is the first meta-analysis in this topic, and we can combine this both direct and indirect evidence, so the evidence of practical applicability is much higher. But there are some limitations, like we had missing details about the printing parameters, and the outcomes were really inconsistent, and this quantitative analysis is only for horseshoe-shaped models. But as a conclusion, we can say the most commonly used technologies are SLA and DLP technologies. All the technologies are acceptable for orthodontic application, but from the prosthodontic aspect, only SLA, DLP, and PolyJet technologies were clinically acceptable. For clinical implication, we can use all the technologies for orthodontic application, but only SLA, DLP, and PolyJet technologies we can use for precise full arch model production in purpose of prosthodontic application. And from the research perspective, a standardized accuracy assessment protocol is necessary to provide comparison, and future studies should involve a standardized reporting protocol about printing details like materials used, post-processing procedure, or other printing parameters. My second project is a comparative study of additive and subtractive manufacturing of fixed dental restorations. CAD-CAM divided into subtractive and additive manufacturing, and we use milling for over 13 years now in dentistry, but 3D printing is a much younger technology. But we accept the same precise results from both of these technologies. However, there are many differences between them. The main difference is the material wastage, because during milling, subtractive manufacturing, we remove the material from the workpiece, and the wastage can be 90%. However, during 3D printing, the remaining material can be reused. Complex parts with intricate shapes and hollow cavities can easily be produced with 3D printing, but milling has limited capabilities because of the size of the milling burr and the angles. So as we can see, 3D printing has a lot of benefits, but we need more evidence about the marginal and internal precision of this technology. So our aim is to evaluate the accuracy of fixed dental restorations made by 3D printing. So we would like to compare 3D printed dental restorations to the subtractive way, and as an outcome, we would like to know how accurate these works are. And our hypothesis is that fixed restorations using additive manufacturing are significantly more accurate than those made by subtractive manufacturing. And with the results, maybe we can establish 3D printing as a more accurate, cost-effective, and time-efficient manufacturing method. I made my search, and I'm at the stage at title and abstract selection. So I would like to finish my project in this summer, and let me close my presentation with this quote. Just remember, you can't climb the ladder of success with your hands in your pocket. Thank you.
You know, okay, I have one question. You know, in the first half of the lectures, it was the 250 micrometers, and this concept was revolving in my mind that maybe it's too large, but you could respond on these questions. And that's why, you know, it was automatically answered my questions immediately, because in case of the short, but mainly in case of the long, extensive bridge, it cannot be acceptable range of the inaccuracy of the digital techniques.